Good afternoon. So, we have been talking about some of the skills that you need to succeed in industry. So, let us specifically look at what chemical engineers are expected to do. So, when you get hired into an industry, you will be expected to review the ongoing manufacturing processes, because as I said earlier, chemical engineers are supposed to be very good at diagnosing processes, understanding their current capabilities and ways to improve them. So, you will be expected to come in, take a look at the manufacturing process as it is, and look for opportunities to improve productivity, reduce cost, or meet other objectives. Quality improvement, for example, would be one of them. So, after you conduct your initial research into the existing manufacturing process, you will be expected to come up with a new design. You may say that the process as it is fine, no tweaking is required, but that would be very unusual. The reason they hire you is so that you can make some improvements to the process. So, you design new equipment, new processes, and but you do not stop there. You cannot just say here is a design, go run it, right. You have to then test and troubleshoot these designs. You have to build prototypes, you have to test them out. Any processes any problems that come up have to be identified at pilot scale or prototype scale and taken care of, so that when you ramp up to full production, the same problems do not hurt you. If necessary, you have to modify the design. Course corrections are always important. You may have started with a design that you thought was perfect, but you will learn during the course of time that there is no such thing as a perfect process. Every process has its flaws, and you have to identify them early and take care of them. Safety is automatically assigned to chemical engineers, because most people still think chemical engineering is chemistry. It is very hard to convince them that there is a difference. And so, anything to do with chemistry, anything to do with chemicals, they will say you are a chemical engineer, take care of it, right. And so, but it is good. I mean, it is good that you are given that responsibility. It is good for job security, because these kinds of expertise, safety, environmental compatibility, these are things that are transferable from process to process. So, if tomorrow this process is shut down for whatever reason, you can still find use running the same kind of safety protocols and environmental impact studies for other processes. Collaboration, again, there is almost a natural assumption that chemical engineers know how to work with people from multiple backgrounds. So, you will be expected to get involved in and frequently manage large projects that have people from very diverse backgrounds working with you, which means again you have to be trained for it. You have to be trained for collaboration, communicating effectively, managing teams of people, getting the most out of them, but not through coercion, but rather again the best way to get the most out of people is by setting yourself up as a benchmark. If they see you providing a lot of value, they will be motivated to do so as well. So, what are some of the skills that industry expects of a chemical engineer? Analytical skills. Of course, all engineers are expected to have this, but chemical engineers in particular, when it comes to process analysis, we are expected to have the most expertise. Computer skills, again, required for all engineers now, but there is a special expectation from chemical engineers, because a lot of the computational application in industry again revolve around processes, and they would say basically as long as you are running the process, you should run all the computing systems that go with the process as well. Innovation, creativity, and ingenuity. Chemical engineers are looked at as the idea people. You are constantly expected to come up with these new solutions to problems or new opportunities for increasing revenue. So, that does put some pressure on you, but it is also good in a way that you are kind of considered the creative forces in any industry, as opposed to it is interesting, mechanical engineers or civil engineers or kind of pigeonholed into very specific roles, and not much is expected of them outside of these roles. Whereas a chemical engineer, maybe because people do not know exactly what your role is, so you are kind of expected to do everything. So, it is a plus and a minus. Interpersonal skills, again, because you are expected to collaborate, because you are expected to lead collaborations, coordinate project work, you have to be really very good at building interpersonal relationships. Math and science skills, again it goes back to this expectation about chemistry, right, and increasingly biology also, because many chemical engineering departments have now been renamed as chemical and biomolecular engineering departments. So, if you are a chemical engineer, not only now are you expected to know chemistry, but you are also expected to know biology and of course, physics and math and all the other subjects. Problem solving skills, again the expectation is that as a chemical engineer you have the know-how to be able to look at a problem in all its dimensions and come up with a solution that is fully compatible with not only the technical requirements, but also the business requirements. So, whatever solution you come up with must not only be technically viable, it should also be commercially viable. Building skills, you are also expected to be good with your hands, you are expected to go in and get your hands dirty. You are not expected to just stand back and direct the work. You are expected to do the work yourself, but at the same time thinking skills. So, I mean in a way chemical engineers are like one of these superheroes. You are expected to do everything in industry. Again it makes you a very valuable asset to the company, but it also means that you have to be much better prepared for your industry role compared to many other engineers who may be around you. What is a typical work environment for a chemical engineer in industry? You will spend a lot of time both in on the floor, either in the manufacturing floor or in laboratory, and in the office / computer control systems room, and you will keep moving between the two. So, you are both a designer as well as an implementer as well as an administrator. So, you have to be able to multiplex. Chemical engineering work can be dangerous. Many of the processes that chemical engineers get involved in inherently involve safety aspects. For example, chemical reactors, right, typically run at temperature, pressure, and you use chemicals in many processes, and all of these have safety implications. And so, you have to be constantly vigilant in terms of protecting yourself. So, gearing up, gloves, masks, eyewear, lab suits. Some people do not like those, they are pretty restrictive. If you have to be fully garmented all day long, it gets very uncomfortable after a while. But again, as a chemical engineer, you may not have much choice. You will be expected to go do your work where it can be dangerous, and it is just part of your job description. You have to get used to it. The plus point with all this is that chemical engineers can find jobs in a wide range of fields, much wider than virtually any other engineering discipline. Petroleum, coal manufacturing, pharma manufacturing, food production. I mean, there is like hundreds of industries that can hire you. Again, as long as they are running a process, they need you. So, it does not matter what the industry is. What you look for is a process that you can focus on, that you can work on, and that you can improve upon. So, if you just look at job descriptions for chemical engineers in advertisements, for example, these are some of the typical job descriptions. Conducting research to develop new and improved manufacturing process. So, one thing you should do is, as you get ready to graduate, you should see how many of these you will satisfy. Will you be able to say yes to half of these, safety procedures for working with dangerous chemicals, processes for separating components of liquids and gases, plan and layout of equipment, tests and monitoring performance of processes throughout production. That is one of the big roles of a chemical engineer. There is this industry 4.0, right, where now kind of tools talk to each other, but then you require somebody to say what type of data is needed in order to enable these tools to talk to each other, and that is where chemical engineers come in. You have to devise the tests and you have to devise the performance monitors that are relevant for the work at hand. Troubleshooting problems, compliance with safety and environmental regulations, estimating production costs for management. Increasingly, chemical engineers are also expected to have the financial expertise to be able to do cost analysis, not just the technical benefit analysis. Specialization is always good. Specialization usually happens when you have postgraduate training, and certainly if you are doing a master's or a PhD at a university, you would have established a specialization. But that can be again a plus and a minus. If you are too specialized, then your job opportunities are going to be limited, which is why in general it is good to get your undergraduate degree in a fairly broad discipline like chemical engineering, but then if you are keen on it, you can get your master's degree in a more specific area like data science, for example, which is why these interdisciplinary dual degree programs are very popular, right. You can get right now at IIT you can get a BTech in chemical engineering and a MTech in data science, or there is like 7 or 8 other options for these IEEE courses. So specialization is good, but at the same time you should also have broad expertise. So what industry looks for is a combination of the two. General expertise to be able to understand various processes and work on them, but with particular expertise in a specific process. Nanomaterials, biological engineering, energy, electronics, food, clothing, paper, these are all industries that are now increasingly hiring chemical engineers. Life sciences, biotechnology, business services, these are some new and emerging opportunities that chemical engineers should look at. So what is the outlook for chemical engineers in industry? Employment is expected to grow roughly 6% till 2028, which is about same as other occupations. So it is not any better and it is not any worse. Demand for chemical engineers depends on demands of products from various manufacturing industries. What you can do, I mean some of this is out of your control, the demand for products is going to depend on the state of the economy. So there is not much you can do to affect that. However, what you can do is continuously retrain yourselves, update your skills, stay relevant, because things change all the time, and if you do not do that, if you rely upon your learnings from a few years ago, your skills may be entirely out of date. And so even when there is a demand for chemical engineers, someone who has current skills will be preferred over you if your skills are outdated. Chemical engineers do not necessarily have to work in manufacturing industries themselves, but even in supplier industries to the manufacturing industries. For example, if you do not have to work in the automotive industry, but you can work in a firm that manufactures plastic resins because they are used in automotive industry. So the opportunities for chemical engineers are all the way up and down the supply chain. Chemical engineering will continue to migrate into dynamic fields such as nanotechnology, alternative energies, biotechnology. However, overall growth, I mean the reason why it is still only expected to grow 6% is because some of these will grow and some of these will die out. So it's unfortunately not all industries that hire chemical engineers are on a growth trajectory. Some are, if anything, phasing down because of reduced demand for products. Certainly this whole alternative fuels business is presenting new opportunities for chemical engineers, but at the same time there is a reduction in the more conventional industries, right, oil and gas. So that is a kind of balance and counterbalance you have to deal with. Integration of chemical and biological sciences and rapid advances in innovation will create new areas in biotech and in medical and pharma fields. So, a chemical engineer with a background in biology can be a very sought after resource. And again, that is the reason why many universities, especially abroad, have combined the two. So, most of them are now chemical and biomolecular engineering. Used to be that environmental was part of chemical, there used to be many chemical and environmental engineering departments, but now environmental engineering has been taken over by civil. So, many civil engineering departments are now civil and environmental. So, what chemical engineering is left with is basically bio and to some extent materials. There are some chemical engineering departments that are also chemical and materials engineering departments. There are one or two that are chemical and process engineering. So, that kind of gives you a feel for where chemical engineering is heading in future. Bio is certainly very crucial. It is kind of unfortunate that here at IIT Madras we went the other way. Bio used to be part of chemical engineering till 2004, and then we formed a separate department for bio, and I think in retrospect probably not a good move. At the time, of course, it made sense, but the worldwide trend is consolidation of chemical and bio. So, India Today January 2020 had an interesting article about chemical engineering. It's good to get these different perspectives of people on what chemical engineering is and what chemical engineers are expected to do. So, this article says chemical engineering is concerned with processes that convert raw materials or chemicals into more useful ingredients and products for varied industries. Very traditional viewpoint of chemical engineering, right? I do not know if it has any validity now. Chemical engineering enables businesses to curtail production costs up to a great extent. I think that is a true statement. No matter what the process, it does not have to involve conversion of raw materials and chemicals into products. Virtually any process, we should be able to leverage our learning to see how we can lower the cost, improve the quality, speed up production. That is why from plastic to iron to steel and cosmetics to pharma, demand for chemical engineers is always more than supply in almost every industry. Well, I do not know, I think that may be true in a global sense, but there is obviously a mismatch of supply and demand. Where the demand is not necessarily where the supply is, and vice versa. So, if you are having trouble, for example, finding employment in industry, it may be more geographical than anything else. It is not that your skills are not required, it is just that they are not required where you are looking for a job, and you should try maybe look outside the country if necessary. Because many countries do have a shortage of chemical engineers that they will acknowledge. Chemical engineering core responsibilities revolve around three key objectives: making process cost effective, eco-friendly and efficient. I think that is again a valid statement. Chemical engineers are also accountable for various challenging tasks such as conducting rigorous researches to develop solutions, helping companies in getting patents, improving production capacities, ensuring employee safety, preserving or conserving resource materials of special significance, producing green or eco-friendly solutions. I think all of these are true. I only take exception to the first bullet, I think, but the rest of it I think still holds true. But again, I think what you should do is some self-appraisal. If these are the tasks that you are expected to accomplish, how prepared are you in doing these? Demand for chemical engineers has gone up due to its growing role in large scale commercialization of nanotechnology and bioengineering. When nano started out, it was just science. It was basically physicists and chemists playing in the lab. The kind of quantities of nanomaterials they used to produce were like micrograms. Then it slowly got scaled up to maybe milligrams. But if it is something that is going to be commercially viable, you have to make these nanomaterials in tons per day, right? And that is where chemical engineers come in. Chemists will only take you up to a certain stage, and then the chemical engineer can step in and say, I know how to make this in a much larger quantity. And same thing with many of the bioscience products. So, demand for chemical engineers in these industries initially was not very high, because they were still mainly in the domain of science. But now increasingly we are seeing that the scale is growing, and therefore the demand for chemical engineers is also growing. This was a paper published by the National Skill Development Corporation, skill requirements and skill gaps in the chemical segment. It's interesting to look at because where the skill gaps are, I think that's where the employment opportunities are. If you can show that you have the necessary skills. So, if you look at the overall segment, chemicals and pharma, PhD, MTech, MSc, etc., only about 5 to 8% of the jobs. Graduate engineers 15 to 25, diploma engineers 10%, ITI and other vocational courses 15 to 20%, other graduates 15 to 25%, 12th standard or below, mostly I guess operators on the line, 20 to 25%. So, roughly a third of the jobs are open to people with higher degrees and people graduating from education such as IITs. So, it's a very competitive scenario in that sense. Even though there are a lot of jobs in industry, not all of them will be offered to somebody with the qualifications that you will have when you graduate. One of the jobs that you should be able to handle is production manager. Now, production manager has a lot of responsibilities, a lot of skills that are required. Managing safety and regulatory aspects, compliance aspects, coordination with other functions, initial setup and implementation of design, coordination with third party manufacturers, with internal departments, breaking down production plan to ensure achievement of production targets, identifying opportunities for process improvement, implementing them, awareness of emerging areas. For example, in the agro industry, used to be that fertilizers were sold in powder form. Now the whole industry is switching to liquid fertilizers, especially as they implement nano fertilizer strategy. Nano just cannot be administered to the soil in dry form. It has to be administered in liquid form. And there's a lot of chemical engineering involved there, not just in terms of synthesizing the nanomaterial, but also the suspension of the materials in water, and also the spraying techniques. How do you make sure that these nanomaterials get to the critical regions? So, a lot of interesting avenues for chemical engineers to explore. Standard operating procedures, overseeing all aspects of operations, ability to lead multidisciplinary teams, achieving maintenance and reliability goals, working with the research team. So, a production manager has to wear many hats and serve in many capacities. So, what are the skill gaps that the industry sees? Why is it not able to hire sufficient number of production managers? Because people, especially the ones that come from outside, do not have an adequate understanding of the basic chemical processes that will complement maintenance and repair activities. Now, so in fact, typically what is done is a production manager is promoted from within, right? But even then, that person has to show that they have acquired these skills. Inadequate exposure to current tools, technology and processes. The problem with promoting from within is, if you have been in industry for some time, again you enter a comfort zone. You're okay with all the equipment that's in your process, you know how to run it, you know how to maintain it and all that stuff, but you may not have kept up with current developments. Whereas, if you come from outside, you may be aware of current developments, but then you won't have that intimate knowledge of the process as it is running now. So, it's a quandary. Inadequate specific petrochemical knowledge, it's more applicable to the petrochemical industry, inadequate knowledge of safety procedures, lack of project specific courses, inadequate knowledge of terminal and container operations. So, this is more for the petrochemical industry, but you can substitute many of these words with other words and they will apply to any industry, right. Another job that is suitable for a chemical engineer is production supervisor, who works just below the production manager. But this is more core work. You have to be able to adjust processing conditions based on process measurements. You have to be comfortable handling data, analyzing data, reacting to data, and taking corrective actions and proactive actions based on data. Feedback on quality of input materials, tracking and recording process information, production data, ensuring cleaning of all process equipment, QA, testing, compliance with safety measures, adequate knowledge of chemistry, chemical hazard, safety measures, calibration, ability to perform routine calibration, ability to monitor operators and communicate with them, documentation, awareness of safety procedures, environmental norms, and knowledge about control systems and process control. So, a production supervisor, again, there is a very specific set of skills that are expected, and the skill gaps that are observed by industry is inadequate practical understanding of chemical processes, lack of knowledge about valves and pumps and so on, lack of awareness of shop floor culture, how to talk to people working on the shop floor and get things done, lack of specific petrochemical knowledge, training and assisting operators on the job. That's a skill. When you step into a manufacturing line as an engineer, the operators will actually test you, they'll challenge you. Even if they know how to do something, they'll pretend they don't know and make you show them, right. It's a quick way for them to assess whether you really know anything or you just have book knowledge. So, you should have sufficient understanding of how things work in general. Poor people management planning skills is another issue. And then we have production and QC managers, that is another job, and the skills required in this case are, and this is written more for drug manufacturing. Contamination is a huge issue in any drug manufacture. So, you should be able to understand various sources of contamination and how to prevent them, maintaining the manufacturing environment at required levels of temperature, humidity and cleanliness, layout and design to minimize errors. Again, particularly in pharma and drug manufacturing, you cannot afford to make an error, because it's not just going to cost you money, it's going to cost human lives. And you're not just going to suffer a loss due to lost production, but you can get sued and you can go bankrupt if you are not careful with how you manufacture these drugs. Identifying avenues for cost reduction, optimum resource utilization, develop manufacturing processes that are adaptable to mass production, ensuring continuing upgradation of skills and continuous education for employees, emphasis on cost effectiveness, intellectual property management, continuing improvements, efficient manufacturing, timely delivery, adherence to compliance metrics. So, these are important things for production and QC managers. And here the skill gaps are that this whole business of quality management is something that is not covered in typically academic curricula, right. And so, if you are a fresh hire, you have virtually no idea about what is quality control, and so you have to be trained from scratch. If you are an internal promotion, you still may not know much about quality management if you have been working in other areas. And quality management is something that requires, again, a lot of mathematical skills, a lot of analytical skills, statistical skills, because most quality management is done through statistical process control techniques, which requires a very good knowledge about statistical methods. Inadequate understanding of IP management, of regulatory aspects, again, people management skills and leadership skills. So, these are gaps in skills that industry is constantly trying to fill. They want people to come to them ready to do these jobs, but clearly that is not going to be possible without some training on the job. And so, that is a constant tussle between academia and industry, right. I mean, at what level are you when you enter industry? Can you step in and close some of these gaps, or is it going to take you some time to really get yourself oriented to working in industry and then try to close these gaps? So, production and QC supervisors, some of the skills that are required, again more details, everything from where do you place equipment, how do you move materials and people, disposal of waste, labeling, safety measures, in process inspection, liaisoning with stores to ensure adequate raw material, technical knowledge about products, knowledge of good practices and compliance to SOPs and quality standards, assisting R&D in process design, ability to undertake batch planning and issuance of batch sheets, monitoring and training of operators. So, these are the skills that you require, and here again the gaps are inadequate understanding of quality management practices, inadequate practical exposure to high quality lab settings. Many of you do work in labs, but an academic lab is very different from an industry lab. Again, because you cannot afford mistakes. Every analytical instrument in industry will have a proper calibration sticker. If the calibration is out of date, again the whole industry can get sued. If you're running production and your analysis tool is not maintaining its calibration, then potentially all the product you are making is defective, and if your customers find out about it, you could be in big trouble. A high quality lab setting does not just mean expensive equipment, it is also how you maintain the equipment, how you take care of it, how you service it. You are not supposed to wait for it to break down, right? You are supposed to be doing things proactively, and in academic institutions you just cannot afford to do that. It is not that they do not want to, but AMCs can be pretty expensive, and an AMC only covers very basic stuff. If you want a better monitoring of the health of the instrument, and you want to make sure that you will not have a problem in future, you have to pay a lot more. So, industry can afford it, academic institutions cannot. Communication skills being inadequate, again IP management issues, inadequate task orientation, leadership skills, all of these can be problems for someone who is trying to become a production supervisor or QC supervisor. So, if you look at the chemical and pharma industry, you can define a skill pyramid. Skill level 1 is where you acquire skills with a short modular learning process. So, you can take employees that have a minimal education and give them a quick training, and you can upgrade them to the skill level 1. Skill level 2 is skills that require technical training, knowledge of complex operations and machinery, supervision skills. Then 3 is degrees, highly involved technical or commercial operations, and finally skill level 4 is R&D. So, again if you look at how people are split between these levels, 20 to 25% of resources in industry will be at skill level 1, 25 to 30% at 2, 40 to 45% at 3, and only 5 to 6% at 4. Now, what that means is, if you are in, let us say skill level 4, you are small in number, but your impact is expected to be very, very high. You kind of have to continuously justify your existence, because if you look at obviously compensation, skill level 4 is going to make a lot more money than 1, 2 or 3, and it is not going to be linear either. It is going to be more like an exponential curve. And so, when companies are looking at their overall profit and loss and they want to do cost cutting, skill level 4 is where they are most likely to get rid of people, because they are the most expensive resources. And so, you have to be able to justify your existence, which means you have to continuously acquire new skills, but also make sure that you are interfacing with people at the other skill levels 3, 2 and 1 to ensure that your value is appreciated all the way through the organization. That is very important. American Institute of Chemical Engineers has defined some career paths for chemical engineers, and so this engineering career consultant and president of Quantum Success Solutions, Alaina Levine says this is because chemical engineers skill sets are widely applicable, which makes chemical engineers incredibly valuable across industries. chemical engineers approach problems in a unique way. They are trained to see pain points, they have the ability to figure out what the barriers are and create innovations to overcome them. I mean, you should feel happy that you are a chemical engineer, but then you have to make sure that you can do all this. You know, when you go out into the real world, these are some of the expectations that people have, and you have to be able to meet them from day one. The traditional chemical engineering career path, working in oil and gas, basic or specialty chemicals, pharma, start as research, process development or production engineers and have job responsibilities including scaling up, designing, planning and testing, directing facility operations. Scaling up is something that is considered a unique skill of chemical engineers. Very few others will even try to claim that they have expertise in that, whereas chemical engineers, you know, we talk about dimensional numbers all the time, right. There is no other engineering discipline that talks so much about non-dimensional parameters, and the value of them is in scaling up primarily. So, that is a advantage that we should try to exploit to the extent possible. Growing demand. So, Anthony Actis says there is demand for chemical engineers who can excel in critical problem solving and can work in multidisciplinary teams. There will always be demand for consultants, facility and process engineers and the myriad of other specialities that chemical engineers can get into. They play a growing role in environmental sustainability, plastics, paint, food products and more. I mean, it is all a good story, right. I mean, the overall impression I get from reading through all this literature is chemical engineers are highly valued in industry, but I do not know if that is a reality, at least in India. I mean, do you guys have that feeling that as a chemical engineer you are a highly sought after commodity in the market? Because I do think it is true worldwide. You know, if you take a more global perspective, chemical engineers are in demand, but the Indian scenario for some reason is very different. I do not know if it's just South India or whether that is same in like Bombay. You know, there are so many chemical industries there, right.
Yeah,
so,
especially in Gujarat.
Yeah. So, I assume IIT Bombay graduates find it easier to get jobs?
No, depends upon the what kind of requirement for the industries, because most of the IIT graduates are not going to the ground level jobs.
Right.
Particularly hiring the companies in the R&D departments or designing departments.
Right.
If you are talking about the Reliance Industries, so less number of the people are working on the ground floor, but most of them just working for the designing, procurement, or EPCM technologies or technology transfer departments after the graduation.
So, it does not matter where you graduate from, it is more.
It is depends upon the which company hiring you.
But in general, I would think there are more openings at, you know, that is a problem, right. There are always more openings at lower levels than at higher levels, and the more highly trained you are, actually the more difficult it is for you to get a job. But once you get the job, you will get paid well, and you know, you will be a valued employee. But so, chemical engineers move around a lot. You know, again, compared to other engineering disciplines, many chemical engineers do not stay in one job for their entire career. They get into project management, they get into technical sales and engineering. Managers, a lot of managers, as I was saying the other day, are chemical engineers because they can manage a process. Consultants. Chemical engineers are expected to be flexible enough to apply their skills across many different job descriptions. Over my professional career, I have experienced major career shifts. My engineering training combined with my thirst for knowledge allowed me to be successful at each. The thing is, moving around is good because usually when you move, you do move to a better position, higher salary and so on, but then you may also be expected to have new skills, right. So, it is also important for chemical engineers to never stop acquiring new skills, so that you are ready for these moves when they become available to you. Pursuing an advanced degree or becoming a licensed professional engineer. Professional engineering does not exist in India, right. There is no PE certification, okay, because especially in the US, if you are a certified professional engineer, you can there are many positions that open up for you that you won't be able to fill unless you have professional engineer certification license. I had no difficulty moving from process engineering to environmental engineering. Core chemical engineering courses, separations, thermodynamics, reaction engineering, transport phenomena, empower chemical engineers to move into careers in process, software, biotech, biomedical, among other fields. So make sure that you learn all these courses well. Some engineers move into completely different fields. There's one chemical engineer who loved to bake, turned baking chemical engineering themed cupcakes and pastries into a successful career. Baking does use knowledge of chemistry, requires problem solving, creativity. So this engineer combined her skill set with passion for baking and developed a unique and profitable enterprise. The idea is that you can use chemical engineering as a launch pad for whatever you want to do. Entrepreneurship is another path that chemical engineers can follow because they are again naturally inclined to do so. They are trained to draw on resources from a variety of fields, adaptable, creative. They can thrive in a process in a fast paced environment. So this interesting example is one engineer got a master's degree in chemical engineering, went to work for a supply chain management company, performed data analysis and coding, because of which he was recruited to work for a startup to design specific algorithms, later became head of the company. The catch is this company is a major online dating service, So again, another evidence that chemical engineers have skills that are applicable virtually anywhere they go. The key is to pinpoint problems that get you excited, that you are passionate about solving, then find a job that lets you solve those problems. Sounds simple enough, but I don't know. Okay, let's stop at that point and we'll continue in the next class. I think I'm almost done with this module. Well, maybe we'll just finish this then. Just have 3 or more slides, 3 or 4 more slides. So this from ACS, American Chemical Society, Chemical Engineering Career Paths. ACS says chemical engineers translate processes developed in the lab into practical applications for commercial production, and then they maintain and improve these processes, rely on foundations of engineering, math, physics, chemistry, and biology now. Main role is to design and troubleshoot processes for production of chemicals, fuels, etc. Most often employed by large scale manufacturing plants to maximize productivity and product quality while minimizing cost. Well, if you can do that, you have a job for life. It's basically what industry wants. Aerospace, automotive, biomedical, electronic, they all require chemical engineers for developing and improving their products. Work in almost every industry, affect the production of almost every article manufactured on an industrial scale. Again, ensuring compliance, conducting research, designing and planning equipment, incorporating safety procedures, monitoring and optimizing performance of production process, estimating production costs. I think there's a lot of consensus among all these publications about what chemical engineers are expected to do in industry. So like I said, by the way, I will post this on Moodle. I do think it's good to kind of review your own portfolio and see how much of this you are capable of doing. And if necessary, take some online courses to strengthen wherever you think you have some weaknesses. Typical chemical engineering workspace, manufacturing plant, research labs, pilot plants, working around large scale production equipment, indoors, outdoors. Again, wearing personal protective equipment is something you have to get used to. Typical workday may involve traveling from one function to the next within a facility. Even if you work in business and management, you do wind up visiting research and production facilities, and interaction with other people who are part of a team is critical. So what are the chemical engineering employment trends? Demand is expected to continue, but at a slower pace at major chemical and pharma companies. As the biotech industry grows, opportunities with a background in biology will expand. Chemical engineering research jobs are increasing in importance with the development and implementation of new energy sources. So I don't know, the message I get is pharma and energy are the 2 areas where you are most likely to find jobs these days. So, get right skilled for the career path you choose. Take all this advice, digest it, and then, like I said, if you find that you need to improve in certain areas, go ahead and do so while you still have the time. Being in an academic environment gives you the luxury of continuing your learning process, and because once you get into industry, you may just be too busy to really, even if you want to, learning some new skills at that time may take a lot out of you, especially if you are trying to manage work and family life. Okay, so let's stop at that point.